we're going to graph the function f of x equals the square root of x. And what we have to keep in mind is that we cannot take the square root of a negative number. The smallest number that we can find the square root for and get a real number back is 0. So we would start with 0, and then we might put 1 in for x, and then 4, and then 9. We can put numbers that are in between those values in for x, but they don't return nice numbers like 0, 1, 4, and 9 would. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And we can plot these points. We'd have a dot at 0, 0, a dot at 1, 1, a dot at 4, 2, a dot at 9, 3. And what we're going to find is this curve that extends out forever to the right and does continue to go up. It just doesn't go up as quickly as it goes to the right. Now, very commonly in problems that request a graph like this, there's also a question having to do with the domain and the range. The domain for this function, in other words, all of the x values that you could put into this function and get a real number back, would start at 0 and then go to infinity. So it could be expressed as x greater than or equal to 0, or in interval notation, it would be expressed as bracket 0 to infinity and then a parenthesis at infinity. The range would be all the y values. The y values would start at 0 and then also go to infinity. So our range would be y greater than or equal to 0, or in interval notation, again, 0 to infinity, with a bracket to open at 0 because we include 0, and a parenthesis at infinity because we can't include infinity.